2000 version 14 video for the 3D frame system. Okay, let's get started. Start SAP 2000. And we will select by a new template. In the new template we will select first of all change the unit to kip foot and select 3D frame. In the 3D frame we can have open frame system. Open frame system we have just frame, no slab. Okay, we can have a parameter frame system. In parameter frame we have slab supported by the by the frame at the parameter. Understood? And we can have a slab beam. So this is one which we will use in our example, a slab supported by the beam and then by column. This which we will use. We can also have flat slab system. Flat slab system we have a slab directly supported by the column. Okay, now in our example we will select slab beam system, change story to 5, height to 18, and go for the base in x5, y3, x direction 25, y 30, number of division to 6. I want to divide the slab by auto mesh, and the slab will be divided into 6 cross 6, 6 in the x direction, 6 in the y direction. This is auto mesh. Slab is integral and slab is a single entity. It is one entity at one panel, but when the analysis is done you will see the mesh in the slab and it will be divided into 6 cross 6. Let's define some edit. First of all we will edit the grid. Edit grid data 018. This is okay. Now this height become 33. This become, because the first height is 18, the other story height are 15, so cumulatively it become 33. 33 plus 15 become 48. 48 plus 15 become 63, and 63 plus 18 become 15, 78. Okay, the bubble size is reduced to 1, and bubble size is the size of the grid display. Here it is represented by ABC, here it is represented by 1 2 3. So these are circled in a dia. That label size, this label has a dia of 1 foot. Okay, press OK. Now we will define some beam sections. Add a new section, go for concrete rectangular. The first section is B, 12 cross 10. Okay, 12 is 1, 10 is this much. Reinforcement type is changed to B, and the top and bottom cover are taken as 2.5 inches. Press OK and OK. Now add a copy. B 15 cross 12. 15 is 1.25, 12 is 1, and press OK. Now the third copy is B 18 cross 12. Okay, 1.5 and 12 is this much. Okay, now add another copy. B 18 cross 15. 18 cross 15. 18 is, this will become the second 1.25. Okay, now we will add another copy. B 24 cross 12. 15. 24 is 2, 15 is 1.25. Why we have defined a set of beam section? We have defined a set of beam section in case when the beam member is failed in design, then we will select another section. If the second section fails, we will select the third section, because the capacity of the member increased by increasing dimension. Press OK. Now first section is selected. We will select the columns. Now add a new column, concrete column, and say column 10 cross 10. 10 is 0.833, and press OK. We don't need to change the reinforcement type because it is already a column. Press OK. Now add another copy. And it become column 12 cross 12 12 represented by 1. Now add a copy, column 15 cross 15. 15 is 1.25, 1.25. Now add another copy, add a copy and column 18 cross 18, and 18 is 1.5, and here again 1.5. Got it? Let's add another copy, column 24 cross 24. 24 mean 2, and column 30, C 30 cross 30. 30 is how much? 2.5. 2.5. Okay. Now one thing to see which kind of bars we have. The concrete is made up of 4000 psi concrete, but if we see the bar is made up of grade 60. Okay, this is what we need. So bar are already by default defined. Press OK, OK, and OK. Now change here the section, column 10 cross 10. Now we'll change the area section. We'll define a slab. We'll take a slab. Slab depth can be calculated by the parameter divided by 180. The total parameter is how much we have of a single span. The parameter is 30 plus 25, which is 55, multiplied by 2, multiplied by 12, and divided by 180. So the required depth of the slab is 7.33, but I'll take a depth of 7.5. Add a new section, and slab 7.5. All slabs will have same depth, and it is keep it as shell thin. No matter, material type is 4000 psi, and it will become 7.5 inches. So 7, let it be 1 foot. I'll change the dimension of this later. Okay, press OK and OK, and select 7.5 is here. Okay, now in the single window of the template we have defined a slab beam system. Number of stories 5, X bay 5, Y bay 3, with the following dimension of beam, column, and area. Press OK, and the slab is generated with us. Okay, now we'll close one of the window, and to see it properly I will fill my slab system. Now to see it more clearly, we will extrude our view, that how our slab is generated. And the more better view in this, we have an OpenGL view, graphic mode option, graphic mode, and graphic mode OpenGL view. Press yes. Now we are looking at the slab in the OpenGL view. Let's rotate our model. In this view you must check that how your slab is connected to the beam. This is very important to check this connectivity of the slab to the beam. Now if we see closely, our slab is connected to the center of the beam. No, it's okay. The slab is not connected to the center of the slab. I mean the beam is connected from the top to the slab. This is called this system is called T-beam. This is a T-beam system in which the slab is at the top and the web is at the bottom. So you must check this thing, that the slab should be at the top and beam should be connected from the bottom of the slab. This can be controlled by the insertion point. Okay, at this moment we have very less thickness, so we can't see it properly. We can't see this properly because the thickness of the beam is very less. Okay, so we want to confirm this. This is very important in our model, and we will confirm this by, first of all, make it 3D. Select select by property and select by the frame section. And by default we have B12 cross 10, select all the beams. So all the beams are selected with us. Now assign frame section and select a heavy section of 24 cross 15. A heavy section is being assigned to the frame, and we have the frame as let's check by the, oh my god, let's save our work here. Okay,